Recording in progress.
Okay. All right, now a bar graph typically has spaces between the bars and is used to depict categorical data. So bar graphs, here we use categorical data, whereas in a histogram, we're using numerical values that are falling in a range of numbers. But here, we just use categories. Like in this case, the bar represents Tom, Dick, Mary, Joy, and Jane. And that's their heights. And here, those bars can be placed in any order. So if you wanted to, you could place the bars in order from the tallest to the smallest, or from the smallest to the tallest. Okay. So pretty much a bar graph, we could read that and find out who's the tallest and who's the smallest. So in this case, Mary will be the tallest and Joy will be the smallest. Or we can find out how much taller Mary is than Tom. Okay. So here we can use bar graphs to answer questions, like in this next example on the next page. In this case here, the figure to the right shows a bar graph of the rainfall in centimeters during the last school year. And let's say we want to answer parts A and B. Which month had the most rainfall and how much did it have? So by looking at this, which month did have the most rainfall? Of course, November, as you can see. And by looking at this, by how much? How much did it have? 30, I'll say about 31. Yeah, about 31. Okay. Yeah, it can be. Yeah. Okay, but I'm seeing 31. Okay, so the month with the most rainfall was November, and it had 31 centimeters of rainfall. And how much total rain fell in February, March, and September?
Did you say February, March, and September?
Yes.
40.
Okay. Let's see. In February, there was 14 centimeters. In April, it was 24 centimeters. And then, wait a minute. Okay. March, it was, help me out here, 21. Okay, it's
14.
Yeah, it's 20. Okay, and then let me go back to February. In February, it does, yeah, it looks like, 14, 20. And then in September, it was 6. So that adds up to 40. So the total rain that fell in February, March, and September is 40 centimeters. Okay. All right, questions on example 5. All right, example 6. Here we got 5 coins are tossed 63 times. A distribution for the number of heads obtained is shown in the following table. And here we want to draw a bar graph for this data. So the top row is the number of heads from 0 to 5, and the frequency for each one of those are given. So let's start by coming up with a bar graph for this. And of course, we need a vertical and a horizontal axis.
That's a silly question. Does it matter which one's going on the side or which one's going on the bottom?
Yeah.
That's why I stopped doing it, because I was gonna do it and then I stopped because I was like, so what should be the difference?
I would
How
put
would
the,
know?
you know, I always put the frequency as the vertical axis. And the other, which is the number of heads, I put that on the horizontal axis. Okay. Any other questions?
You put the frequency on
Which one?
the side? I'm sorry, which one are you putting the numbers?
These, the 0, 1, 2, 3, 4, and 5, those are the number of heads. And then here's the frequency on the left, on this vertical axis. That's the frequency. And in this case here, we're going from, let's say 3 to 20. Let's start by 0, and then 5, 10, 15, and 20. And from that, we go ahead and draw the bars for this. So the number of heads where there was 0 heads, that frequency was 3. Now, of course, 3 would be somewhere, I'll say about right here. So I'm gonna draw a bar at the height of 3, like this. And then for the number of heads, there was like 1 head. That frequency was 8. This is out of 5 coins, by the way. Well, let's say 8 is about right here. Now, since this is a bar graph, these bars are not going to be next to each other, because this is not actually a histogram, it's actually a bar graph. Okay. And then 3 heads, there was, no, 2 heads, there were 20. So 20 is way up here. So I'm gonna try to draw the bar at the height of 20. And then the number of heads for 3, that frequency was 20 as well. So we'll draw another bar at the height of 20. And then for 4 heads, there were 9. Here's 9. We'll draw a bar at the height of 9. Like this. And then finally, there were 3 heads. Well, actually, 3 times that there were 5 heads. So at 3, yes. Okay. So this is what a bar graph would look like for this situation when we toss 5 coins 63 times. This is based on the number of heads that were given. All right, questions on example 6. All right, so next we'll go to what a double bar graph looks like. Okay, now we won't do one in this class, but just want to show you what it looks like. It can be used to make comparisons in data. So let's say we had a double bar graph that looks like this. This is the ages of presidents at death when they died. Okay. The green, as you can see, are the ones for the later presidents. And then for the earlier presidents, they're in blue. Excuse me. Now, I'm not sure what they define as later presidents and what they define as earlier presidents by year, but this is what a double bar graph will look like. You can pretty much see the frequency. It can be on the horizontal axis if you like, and the decade can be on the vertical axis. Okay. Any questions about a double bar graph, what it looks like? And there are other bar graphs like the percentage bar graph. Now here we have a table showing the various types of shoes worn by students in one class and the appropriate percentages of students who wore them. Okay. So this is what the table looks like. You have the frequency, and then each one of these is the percentage. What they did was they added the total frequency here, which came out to be 29. And then each frequency was divided by 29 and multiplied by 100 to get 4% for dress shoes, 14% for flip-flops, Crocs 24%, loafers 10%, and tennis shoes 48%. Now here they rounded to the nearest percent. So in this case here, it might not add up to 100% exactly. But here's what the percentage bar graph looks like. Pretty much it's just bars that lie on top of each other. Okay. And it's pretty much a different heights. Now, also you have something called the stacked bar graph. Okay. So this is what the stacked bar graph looks like on the next page. This comes from the table shown about expenditures of a business over a period of years. Okay, so here they have this in two separate categories, materials and labor. So if you use a stacked bar graph, it will look like this, where the materials are on the bottom, and then the labor, the percentage for labor is on top. And notice that the heights total 100% for each one of those, okay? So they must have, taken the, added up the total for materials and the total for labor, and then came up with a percentage for that, for each one. And it looks like this. Okay. And then finally, you have what they call the circle graph, which is called the pie chart. And it's used to represent categorical data, and it consists of a circular region partitioned into disjoint sections, with each section representing a part or percentage of the whole. Okay, so here you can see how those parts are related to the whole here. And this is an example of the US population by age group, according to the US Census Bureau back in 2017. You can see this big blue piece of the circle represents like 52.7% that are between 25 and 64. So we can say over half the population are between 25 and 64. And in this case here, for the white, 12.4% of the population is over 65, well, 65 and over. And under 5, pretty much 6.8%. All right, now in this final homework, final example here, it said a class of 8th graders undertook an ambitious project to compile the most dominant color of uniforms for all 487 middle school sports teams in their state this year. Here I want to use the circle graph to the right to show the results. Approximately how many teams represented, approximately how many teams are represented in each sector. Okay, so now we're dealing with 487 middle school students. And now we want to find out how many represent each of those groups here. So the one that we're starting in black here, and they tell you the percentage, 21% have black as their dominant uniform color. And this is of the 487. So this is 21% of 487. And pretty much when you do the math here, change 21% to a decimal and then multiply that by 487 because the word of does mean to multiply. How much? 102. Yeah. So this means 0.21 times 487. And this will be 102. And we're just going to round to the nearest whole number. Reason being is because we can't have a fractional portion of or decimal portion of an 8th grader in a middle school. All right, we're told that 18% of the uniforms have a dominant color of white. So this is 18% of 487, or 0.18 times 487. It'd be 88. Approximately 88 of the uniforms have a dominant color of white. And then for navy blue, we're told that 22% of the uniforms have a dominant color of navy blue. So if we do 0.22 times 487, how much? 107. And then for gray, uh, 15% of the uniforms have gray as its dominant color. So that's going to be 0.15 times 487. Be 73. And then marooned, 8%. $87 or 0.08. times 487. Be 39. And then finally, for other will be 60%. So 0.16 times 487, 78. So that's how we can interpret a pie chart or a circle graph. Now, I will tell you that a circle graph will not be recommended, especially if you're trying to create a pie chart like this one. The reason I say that, well, a graphic designer doesn't even recommend it as well because of all the ink that it will take to print one of these out. It does. It takes a lot of ink to do this. All right, questions about section 10.2, dealing with displaying data, and that's only part 1. Okay. All right, so next we will look at part 2 of displaying data.